Only he thought that was funny, but that's all right. It's late in the day. Anybody want a nap?
Yeah.
All right, so compost. I've been working with compost for, well over a decade in vegetable production systems. Why? Because we generally get new composting operations in and they're looking for people to use their compost, and so we try to do some research to see where it might fit, try to evaluate whether, the quality of the compost, and then they either get put out of business or state shuts them down or they don't make enough money and boom, they're gone. All right, so it gets frustrating for us in the research because once we start working with a compost, now they're no longer making that compost. I get a little bit excited again because one of our more, how shall you say, stable businesses in the region said, we're going to get into composting. That's Purdue. So Purdue converted that area that they had in their pelletizing plant. They're no longer producing pellets, and they're all into compost now. So that got me excited again. Maybe we'll have a source that'll be there for a while, all right? Start working on. Well, what is compost? You can read the definition, but it's a controlled process. You're going through phases. You're developing a mixture that's going to be able to heat up. Microbes are going to be using the carbon in that material, and then eventually you'll have a finished product that's pretty stable. And it's a high organic matter, high humic product. So, why should you add compost versus a manure to a soil versus just growing cover crops? Well, that's something we're going to get into today. Why do people compost? They're getting rid of waste materials or what they consider waste materials. Or if you're on a farm or you're going organically, you may have some other reasons why you want to compost. You want to destroy microbes that could be a problem for food safety. You might want to destroy some disease organisms that are in the material. So there's other reasons to compost. So where is it being used? Organic farms, compost is oftentimes a base of what their soil fertility is going to be maintained with. Vegetable and fruit farms, particularly vegetable farms, have really taken to using compost to quickly change the health of their soils. They offer some advantages as far as producing better quality produce oftentimes. And not only on a small scale, but nationwide, there's been a move to using composted manures. Again, for big reason is for food safety reasons. So we're going to heat that manure up, we're going to compost it, and we're going to destroy any potential E. coli, salmonella. Field crops, not so much. And we'll talk about that as we go on, what the issues are when using them in field crops. Why can't we use them in field crops more often? And it's an economic. It's for economic reasons. We certainly use them in greenhouses. We're developing potting mixes using compost. We've used them in the nursery industry forever, compost. And of course, probably the biggest use, and where Purdue is really targeting most of their first efforts in marketing, is with the landscape industry. All right, because it's a great tool for maintaining and improving landscapes. So why do we keep going in these cycles where we have compost, don't have compost? That's part of the problem. Is it going to be available? Is it going to be available in a consistent form? That's been a big issue. And then cost. All right, it's not manure, but if those folks in the manure transport programs, it costs money to move manure around. And oftentimes they have to be subsidized. Is anybody going to subsidize composting? Well, a lot of municipalities do that. So they'll get rid of their waste by composting it. Currently in our region, in the particularly Delmarva area, we only have a handful of communities doing their own composting. Generally, they're having other folks take that waste and use it. So not only do you have the cost of the material, whoever's making the compost wants to make some money off of it. If they don't want to make some money off of it, they're not going to be in business very long. That's been a problem, is we'll have these operations that they take in, they get dumping fees for taking in organic materials. That's their money center, dumping fees. Then they have no place to go with the compost because they don't have a good plan for marketing that compost. That's what happened with a couple of the operations in our region over the years. Purdue's not going to be like that. Not that I'm promoting Purdue per se, but they know how to market things, all right? And then transport, the further you are away, it's just like manure. You're hauling a organic material that's very bulky. So it's going to cost a lot to move it, and then it costs money to spread it, just like manure. So those are all the things that you have to consider when you're doing economic analysis. And that quality consistency has been an issue at times. All right, so as I said, one of the biggest uses has been in organic vegetable production, organic fruit production, and continues to be, it will continue to be a place that's going to consume a lot of compost. This is what I was referring to in California, other areas in the West, particularly where they're growing leafy greens that were an issue. They're composting on board. They're using manures in those operations, but they're all being composted now. So let's talk about some of the systems out there available that are being used to make compost. By the way, that's not compost. That's what I used to do in the back of the barn when I was growing up and had dairy cows. We'd throw the stuff out in the pile. It'd rot down some. All right, but that's not compost. It's not a controlled process. There are plenty of systems where people are bin composting. Of course, we use that had used it for poultry mortalities forever. But there are farms that will set up these bin type systems, particularly if they have bedding pack type of manures. They'll put them in the bins, they'll keep turning them and produce a nice compost. That's an option for any of you who are working with some farms. More commonly, what is being done is these Windrow type systems where they're taking in waste from the farm and then maybe bringing in some other waste, food waste from the community, and they're producing a compost that way. This is an operation up in Pennsylvania. This is where it takes it to the next stage, is when you get into static pile composting, and most of our commercial operations are doing this in some way, shape, or form. This is Purdue's facility. So they have a process, the same thing, it's a static pile type of compost. They're blending their feedstocks, which we'll talk about in a little bit, and they're putting them in these trenches that have an aeration vent underneath, and they're covering them with a specific type of fabric that allows for some of the gases to get out, carbon dioxide of course, but it doesn't allow odors to get out. That's the big thing with a composting operation, is if it's not done right, it smells. And nobody likes to live next to a smelly place. So that's the system they're using, this Gore system. It has that special cover. It has the aeration channel. They have oxygen and temperature probes, and it's all tied into a system which changes the amount of air that flows in through the pile. We've had a few in-vessel systems in the region where you're using a large version of the compost drum in your backyard. They're very costly. You just start up with, and the throughput is not as, you don't get as good a throughput because you have to all go in the vessel. Now, it doesn't take very long to compost in one of these because they're constantly aerating, but it has limitations as to volumes. everybody here should know the phases of composting. You start with the initial phase where the microbial population starts to build up. Once that microbial population builds up, then it goes into a heating phase. And then you go, and that heating phase can last a very long time depending upon how much aeration that it gets, and the feedstocks, the temperature outside, the size of the piles that you're using. And then it goes into that curing phase. And the microbial population changes quite a bit from this phase to this phase. You start off with bacteria really active, and later on you're getting fungi, actinomycetes are more important. What the microbial profile of the compost is going to vary quite a bit. Vary quite a bit with your feedstocks and your end product. And that is important as you're evaluating that compost for some of its benefits. And one of the things that we find is that certain composts tend to be disease suppressive in soils. And it's all because of these organisms that are building up into curing phase, or are there in the curing phase. And you can alter this to some degree. The science, the science isn't really there as to tell you, what recipe to give you the best pest suppressive compost, but we do know that there are differences in compost. And it all starts out with feedstocks. So what you mix together, it all is based on what their carbon and nitrogen contents are. Microbes are at that 8-to-1. They can utilize a material and decompose it effectively if your CNN ratios are 25 or less. Once it gets above that, then there's just not enough nitrogen in the feedstock to support that microbial population. So your composting slows down. So therefore, part of the science of compost, those of you who are composters, is knowing how to blend the materials together, get the right ratio to get good decomposition, get good heating, and not take too long to produce a compost. So around here, we usually have kind of 3 different sources of compost, or 3 types. You have those that are done with agricultural products. They almost always have manure in the blend or some kind of animal byproduct in the blend, and then they'll add the other high carbon materials. You have the food waste. Those folks are trying to compost food waste, like universities do that. A lot of places want to reduce the going into waste stream, food waste. And then you have the yard waste-based systems, where they're trying to compost things coming out of the landscape industry. Each one's different and may give entirely different performance in the field. So that's something that you need to consider as you're trying to evaluate compost. For example, those that have manure in the blends generally are going to have higher nutrient values than yard waste compost. So you actually will get some, you can value those nutrients, and if you use high enough rates, you can supply most of your nutrient needs for a crop. You can't do that with a yard waste compost. So I just pulled these off some charts of some of the interesting materials that have been composted over the years and what they're seeing ratios. Paper, very high. So, remember, we need to be 25 or lower, 400. Corn stalks, 60. Grass clippings can be fine. In fact, that's where you use the green waste type of compost. They're getting leaves, green leaves, they're getting things like grass clippings. Garbage compost just fine. That's why food waste compost works. The trouble with garbage is it comes in with a lot of moisture. So you tend to need to blend it with something much lower moisture. Wood products are commonly used if they're available. What's the issue with getting wood waste now? It's valuable. It's hard for people to get wood waste. So it's no longer just something people are piling out the back of their operations. Poultry manure, certainly, this happens to be layer, very compostable. Horse manure, it's in that area, depends on what the bedding is, all right? And let's see here, leaves, again, need a nitrogen source to compost. Paper again. Of course, we know that poultry carcasses do fine. Raw sawdust, very high carbon to nitrogen ratio. And then straw, which is oftentimes used, again, very high. It's amazing all the things people have tried to compost in the past. All right. So what's Purdue doing in their plant? Well, they've got a bunch of waste products that they want to get rid of. They have poultry hatchery waste. What that gives is eggshells. And eggshells have what in them? Calcium carbonate. So it's kind of lime source. And usually compost, they're going to use some kind of liming material. But in this case, since they have it already in there, they don't need to. Then whatever a dissolved air flotation residual from wastewater treatment plants in poultry slaughterhouses. I think that's like pond scum, skimming off the thing, but I have to ask them what that actually is. Poultry litter, of course. So that poultry litter that was going into pelletizing is now going into the composting. Right. Wood products and yard waste. So this is one of their piles where they're starting to blend all those different materials together. By the way, they're just happy as a clam to have you all come and visit them. All right, they would like people to see their facility and start to utilize their material. All right, so any questions about how compost is made? Most of you in the room are probably experts at this versus what I am. But do know that to do it right, you have to do it in a controlled manner. And to have a consistent product, you have to have a consistent supply of materials. So that's one thing. If you're going to buy compost from a facility, you want to know, is it going to be, how similar is it going to be every time I buy it? How long does it sit before it arrives to wherever it's going to be used? That's going to change a lot of things. We'll talk about that in a second. So if they're moving it a lot, then you know it's going to be consistent because it's the same age that they're moving. But a lot of these places, they'll pile compost for years, and you might get in a 3-year-old compost. A 3-year-old compost is not a just finished compost. It's much different. So how do you know what's in your compost? Of course, you want to get a test result from the company. And I've seen many of these over the years, and they're quite confusing oftentimes. There's a couple procedures. Penn State has compost testing. The National Composting Council does compost testing, and then there's all kinds of other labs that do. To me, if you can get a report with the most information on it possible, that's best, because it allows you to evaluate that compost better. So that's the Purdue results. I'm going to show you this is from the Composting Council. I'm going to show you from Penn State next. And you'll notice that they're not the same, which troubles me a little bit. And so, 1% to 1.5%, I'll show you the next one, of nitrogen and phosphorus. Very low potassium. That's our kind of really, I didn't expect that. Oftentimes you'll see more potassium in compost. Potassium can actually build up in compost as the composting process takes place. This means that they probably have less manure in there than I thought to begin with, less poultry litter. You have calcium. Where's that coming from? Eggshells. And moisture. That's a big deal in compost. When you're buying compost, you're buying about half of the compost load will be water. And if it's got too much water, it doesn't spread. And if it doesn't spread, it's a nightmare. All right? And we've had that problem with compost, people using compost and the other thing is that it does, if you store it and you store it outside and you don't have it covered, Compost absorbs a lot of moisture, so it's no longer the same material. Until it crusts over, kind of like a poultry pile, it can do that. Don't let the weeds grow up on it, too. This is a joke between me and Beck. Yeah?
Is that considered compost by the council, that score that they got? I have a client who's got tested,
Right.
trying to get what they, and I don't know what the scores are off the top of my head, that say it's actually official compost.
Yeah, this one did pass their results, yes. So you have to meet a certain criteria for the National Compost Council to consider it compost. One of the biggest thing is maturity index, and we'll get into that. All right. So the stability and the maturity, which are here's maturity, here's stability. Those are two big things with how you value that compost. We'll get into that in a second. They also look for pathogens. They look for the toxic materials and basically metals, so that they aren't too high. They have to pass EPA guidelines. Here's the Penn State analysis of the same thing. Notice the nitrogen's a little higher in this analysis. So that bothers me a little bit, that you have the same material, two analysis, and one's a little higher. So I need to figure out why that is. And of course, they're going to give you ammonium. Compost has very little compared to manure. Manure has ammonium in it. And how much ammonium nitrogen, like in a poultry litter, will determine how much readily available nitrogen, immediately available, is there. Compost has almost none. All right, if you are at a compost and the compost isn't finished, which I've had that get in a batch, you stick a shovel in it and it's still hot and you burn your nose coming out. Okay, that means it's not a finished compost. So that compost is going to behave much differently than a truly finished compost. So that one probably wouldn't have passed their standards, that one I was referring to. All right, so let's go into just another compost I got in, and you can see the other thing is they have test results on dry weight basis versus wet weight. Well, what are you buying? Are you buying the dry? No, you want to be looking at the wet, because that's what you're going to make all your evaluations on.
They sometimes call it as received.
Yeah, and we'll see that in another one. Right. Again, we'll talk about more of these in a second. This is what I like to get. If I can get a compost where it gives me as much detail as possible. So here we have the nutrients that are contained, ammonium and nitrate. You shouldn't have much ammonia at all. You may have some nitrate, but it'll be very little. Because remember, the microbes are utilizing the nitrogen in that pile. So most of what you're going to get in the end is organic nitrogen. And you can see here's your organic nitrogen. And so total nitrogen 1.5, organic 1.4. What does that mean as far as utilizing that compost in production? How do you in manures, how do you value that organic nitrogen? How much of it is going to be available? All right, it's oftentimes less than half for that first crop. And then you get a little bit every year after, but it'll take you 10 years to get almost the whole value out of it. Compost is even more complicated because those plant available nitrogen values can be very different according to how mature it is. Actually, an immature compost will give you more nitrogen, but doesn't give you all the other benefits that we want. Then you go down and you can see some of your other secondary macronutrients. Not a whole lot of magnesium, not hardly any sulfur, which I found kind of interesting. And as far as the micros, nothing excites you there. All right. You want these, though, to make sure that they're low. And here's the EPA limits. You can see Where there are limits, all these are below those limits. You know, things like arsenic, copper. Where would you find elevated levels of things like copper and zinc in your feedstocks? Well, where do copper and zinc come from? Or how would they get into a waste stream? Pipes, you know, galvanized stuff, copper pipes. So again, that's where you're using things coming out of municipalities oftentimes. And that's why sewage sludge is such an issue, is because you got all the things running through pipes, and as well as people throwing things down the drains, and you get all kinds of nasty things, industrial areas. So these can be way out of whack if you're trying to compost sewage, which we're not going to talk about all today. These are really important indicators, is how much carbon dioxide is still being given off. That's an indication of has the microbial activity settled down and stabilized. These numbers should be very low. They should be below 2. There's two ways they measured it. This is, and just two different ways to test it. You want this biologically available carbon in a finished compost to be around 2 or less. That means it's finished. The microbes are done doing what they can do for the most part. And that will mean that your plant available nitrogen will be stable. We'll talk about that in a second. Another indicator is if there's toxic materials. A young compost can give off all kinds of volatiles that will kill things. So you can actually apply a compost and kill your crop because it's not finished, because of these different volatile compounds. And how do they test that? They actually plant it into cucumber seeds into the compost to see if they die. Other things, big problem with municipal compost is plastic, glass, metal, sharps. I've gotten in compost with all kinds of pieces of glass and plastic because they're taking in stuff in a municipality. Do people separate their things the way they should? Or do sometimes you throw things in the compost bin that shouldn't be thrown in a compost bin? All right, yeah, I see you. Then the other thing, and we'll look a little bit more in depth at this, is size distribution. This goes into will it spread evenly. Nothing worse than, any of you work at a fertilizer plant where you're blending dry fertilizers? You know, like if you're blending urea with potash, urea is about 1/3 less dense than potash. So when you put them in a blend, what happens? The potash is flung out and urea is flung in. You know, it doesn't go as far. Same thing with a compost. You would like to have a even bulk density in those particles, and you'd like to have, you want to screen out the big stuff, but you don't want to have all fines in there, right? That's kind of an art to do that right. And we'll talk more about that in a second. So I like these charts because they kind of explain what you're looking for. So the question you want to ask, is your compost stable? That means, is it going to decompose much more than it has already done? And the way you look at that is to actually, is it still giving off carbon dioxide, and how much? Because that's what happens when microbes decompose the compost. So in this case, that compost that we were looking at just a minute ago is stable because it's not giving off much carbon dioxide. If it's giving off a lot of carbon dioxide, you need to take that compost back, give it back, and say, hey, you haven't finished your compost. It's not going to do what I would like it to do. Maturity is, again, another, how long has it been aging? So the maturity of a compost, one way they look at that is how much ammonia is being given off, or how much ammonium nitrogen is still in there. If it's a lot, then it's not mature. pH can be an indication, and certainly this You know, is it still giving off toxic volatiles? No, because my cucumbers didn't die, all right? All right, so that's another one of those tests that they use to look at maturity. One of the things that I also would like people to really look at in evaluating compost for use in any kind of application is that pH. pH on compost is often very high. I mean, very high. I mean, it's above in the 7s. And why is that? They often add lime to the compost to stabilize it. It's kind of like they're doing with sewage sludge to stabilize it, where they're adding lime in that process in the blend. Or they'll be adding those waste products that have high calcium carbonate, like eggshells, something like that. That has some issues with how much you can apply in a field. All right, because you've got liming value in there, and if you put in 15 tons of compost with a quarter ton of liming value, how much lime have you just added to the field? Is that too much lime? All right, so that's something that several people have gotten into trouble in the past with a high pH compost that has high liming value. All right, does it provide nutrients? So that's another question. Well, a lot of folks are selling compost. Oh, I'm not selling any nutrients, I'm selling a soil conditioner. All right, well, okay, it does that, but if it's a manure base, has manure in it, it's going to have a fair amount of nutrients in it, comparatively. It's not going to be like the manure it started with, but because it's going to lose a lot of that nitrogen in the composting process. But it's still going to have nutrient value. This one, as far as all the nutrients, they gave it an average compared to other composts. You get some will get up into this high nutrient content category, but most of them will be in this range, so about 3% nutrients. The plant available nitrogen is, how much is that going to be released in the first season? This one's really low, 4 pounds per ton. In general, I would say most are going to be in that 10 range for yard waste, maybe 5 to 10 yard waste based. For manure-based compost, it'll be from 10 to 25 plant available nitrogen per ton. But it's going to vary dramatically. Carbon nitrogen ratio, so it's at 13, so it's down to usually in the 10 to 15 range. You're fine there. Electrical conductivity or soluble salts. This is a problem with some of our manure-based composts. They build up salts. I've had that problem with particularly mushroom soil composts. I've killed things with mushroom soil-based compost, so sorry.
And a lot of micronutrients, and sometimes the pH is really funky.
Yeah, so that's where they take the soil out of the mushroom houses, and you can get it without being composted, and that has its own issues. But once it's been composted, it oftentimes really concentrates the salts. So you can only use a certain amount of it then. Otherwise, you start killing plants because you have high salt levels. And then this lime content. This one's very high. It's about over a quarter ton of lime per ton of compost. Now that's worth money to you, right? You're getting lime in the compost. So but you can't only use so much. Otherwise, if you have certain pH you need to be at, you can, now it isn't a one-to-one because you're adding organic matter and it doesn't work as direct liming value as you would think, but it's close enough, so if you have that kind of value, that's very high. Ash content, just telling you how much of that is, when you ash it, how much of it is burn off versus the minerals are still there. Ash content should be high in a compost. That's showing you it's mature. Microbes have done their job, gotten rid of a lot of that carbon. By the way, in the composting process, you're going to lose anywhere from half to 2/3 of the carbon. It's going off as carbon dioxide. Boy, that's not a good thing, that's greenhouse gases and all that. So. Of course, all of you are doing that right now, too, unless you stop breathing. I got a bad sense of humor, sorry. All right, so the big issue is, do you have plant available carbon? I need to keep myself on track. You know what time it is. Ooh, 15 minutes. Ugh. All right. So one of the big things we have to do is determine is how much of that nitrogen that compost is available. And if your biological available carbon is low, then it's going to be pretty low. If it's high, then it's going to be high. But these oftentimes aren't finished composts. Generally, you're going to be probably in this range. So let's look at that. This was some work in California where they looked at a bunch of compost, blend compost, have poultry manure in the compost with other materials, green waste, or just what it says, made out of green waste. And here's the percent nitrogen release as high, and this is very immature, moderately mature, mature, and very mature. So the highest they've got is a little over 50%, but it drops down precipitously once you get to a certain maturity stage. And so look at the range there of the pounds of nitrogen per ton. You need to know this information. How are you going to do a nutrient management plan if you don't know this? It isn't often provided to you. That's a problem. So you can go on these maturity indexes. If it is just finished and become mature, that's probably what you want. Then it's still, it'll be lower in that releasing carbon, but it will have finished and giving you highest nitrogen value. By the way, this would be where you want to buy it for disease management also, because there are the good compounds. You want to get a newly finished compost for disease management. If it's old, it's not going to do that, the same thing as if it's just finished. You look at the green waste, much less. So just a graphical, I don't know what's going on with this one. It's actually using nitrogen again, or tying up nitrogen again. I can't figure that one out. This one here. But you can see just in general, the manure-based are going to be higher. You want to get it right in kind of this range for the highest nitrogen value. So you need to know that from your supplier. Buy it once it's just as it's finished. That'll be probably the best value. So you can also do these cost comparisons with them. So what is the actual value of that compost from if you valued those nutrients at current prices? So I did 2 of them here. We're looking at, and at a higher availability, 1.5%, you get that nitrogen. Here's phosphorus. Phosphorus availability, you look at the research, it's all over the place. That's the one thing that I won't tell you here is how available that phosphorus in that compost. It can be pretty available, it can be almost not unavailable. That's another one that gets you. And of course, this is of no value if you're in a high pH soil to begin with, which we have a few of those on the Delmarva Peninsula, or around dairy farms, that kind of thing too. Very low value of, and lime, that's pretty good lime value, but I was using a commercially spread value. Well, you're going to be paying for spreading anyway, so you're not going to get the spreading value out of that lime. So let's look at it a little bit different. So let's say it's only about 1/3 available. That's what you get. Only about, again, 40% available for phosphorus. That's a value. And lime valued at the actual value of lime coming out of a quarry, and you're down to about $15 value. Take out the phosphorus in a high phosphorus soil, you're down to about $9. So this is the kind of thing how you really wanted to look at that compost. How are you going to get these figures? These are ones you really have to work at on the availability. And a lot of times they're not going to have that information for you. If you can get a report where it gives an estimated plant available nitrogen first year, that's estimated available nitrogen first year, that's what you want. At least they've gone that far.
Quite a few of them have started doing that.
Yeah. Have to do it. I mean, otherwise you can't do a nutrient management plan.
One, it's really hard to fill out your annual implementation report.
Yeah, that's for sure.
Math.
Yeah, that's for sure. The other cost assumptions when using compost is that you're going to have between $20 and $25 just to get the compost to your farm, usually. There are exceptions, like we had a composting operation that just had way too much surplus, and they were giving it for free for people to haul. All right, that's not usually the case. But it does happen. spreading cost. And so you can look at like an 8-ton or 5-ton application rate, how much you've got involved in that. We already talked about this. One of the different things that makes it different from manure is you're going to have your nitrogen availability is going to be much different. And it may have salts, may have higher phosphorus, but that phosphorus could be tied up so tight in an organic form that it can't be used. And it kills pathogens. Spent mushroom soil is not a compost unless it's been composted. We can talk about that another time. We talked about the spreading ability. Where you look at that is you have these medium and heavy density materials. How even across the different size ranges, of course you don't want big stuff and you don't want teeny tiny stuff, but across this range, you know, anything real small, is at the same bulk density. That means it'll spread pretty well. All right. And so that's why you have screening. Good screening is critical in a compost operation. And there you see a screening operation. I've worked on using compost as part of soil health programs for vegetable crops, you know, being a vegetable person. And certainly I have seen times where compost has had good effects on plants. We recently completed some research with root knot nematode, showed very little effect by adding compost. A little bit of reduction, but not much. But with other disease organisms, yeah, it has good effect. You know, we're in vegetable systems, we allow soil disturbance, so you're burning off organic matter. Rotations often allow for diseases to build up. And so we're looking for things to improve the health of the soil. One thing compost does different from cover crops and from manure additions, it has a quick increase of soil organic matter content. Within that application, you can change with a like 8-ton compost, you can increase your organic matter content oftentimes by 0.25%. Put a 30-ton, you can increase it by 1%. That's worth something. Everybody knows a percent of organic matter is worth a lot. How do you value a percent of organic matter? I wish I had a way of doing it, but we know that your crops are going to be much better once you get over 2% in a lot of our soils. Also, they can help in creating a pest suppressive soil, and certain composts are much better at that. I always like showing this slide. It's out of a review of different studies where they got up to 74% control. That's a Phantomyces with an 8-ton compost weight. That's really good control. Unfortunately, this is one on you like. Look at this sewage sludge. They're putting 32 ton on. That's a lot of. It kind of got a lot more Phytophthora in there, right? A little water holding. Andy did work on Phytophthora. So, but you can see, depending upon the type, once you get into these really high rates, they cause us a lot of issues. So some of these are absolutely insane rates. Really, you know, in the 8, 9, 10 ton range, that's probably where we'd like to be. But there's good research showing that it all depends on what disease you're working with and what the compost is. That's why we need to do research with different composts. So that's something I'm really interested in. This Purdue compost doesn't have disease suppression ability. So that's something I'm going to be looking at. Looking for another graduate degree? He's laughing, and no, he's not. All right, so here's some work that we did on melons a number of years ago. Just to give you a bottom line, we had an increased melon yield where between no compost, this is on a poor site that has some soil health issues, and we got that at a 7.5 ton rate. We didn't need to go up to 30 tons. 30 tons just caused some problems. So if you look at what that would be in reality, it would be an increase of $2,500 in using compost versus no compost. We got, even in a good soil, we got a $1,500 net increase. And zucchini work, by the way, zucchini trials are a pain in the butt. They just keep coming and coming and coming. Here we saw about a 500 net increase in compost plots when we got up to 6-ton rate versus no compost. We worked with processing vegetables, saw very little because we couldn't put enough on. Now the question is, if we did this year after year after year, it probably would change. And we looked at watermelons. That's one that we thought we'd see a big benefit to. But in the years that I tried it, we didn't see any benefit of applying the compost, at least at the rates we were using. Here we compared it with manure, really didn't give any difference compared to regular fertilizer program. That's a one-year trial though. The problem with doing compost is if you're going to do it, you're doing it year after year after year. It's going to kick in the second, third, fourth year, the benefits, like any organic material. Some California work showing some great value in certain trials where you're using high value crops. For agronomic crops, not so much. On some of the organic systems where they've used composted, like composted swine manure, they've seen after you get into the third, fourth year, they're seeing much improvements. Just to mention, it also has just very good applications for correcting problem sites in horticultural applications, particularly turf. And then again, it has some value and it's being used in greenhouse applications. And there's a lot of research on that if you'd like to look it up.